Assalamualaikum. Okay, so I'm going to explain to you on how to sketch your box and whisker plot. Okay, so box and whisker plot is actually a kind of graph. It's more like a sketching, okay, which consisting of a box, okay, just like in this one. So this is your box, okay, and then we have whisker line. So whisker line is just a straight line, okay, something like this. Okay, so we are having the line at both ends, okay. So this box will display five important information. Okay, so the first one, okay, so the first line here, this is your Q1, okay, and then in the middle should be your Q2. At the end, the other end is your Q3. Okay, what about this one? Okay, at both ends of the whisker, it should carry some important information as well. Okay, so the left side of your whisker, at the end of the left side of your whisker, this one, okay, this one I'm referring to this part. This one is for your lowest data or smallest data. Okay, for this one, at the right end of your whisker, it should be the biggest data in your data set. Okay, and in the other hands, another important information that you can add onto your box and whisker plot, or sometimes we refer it as box plot, okay, is also a lower boundary and the upper boundary. Okay, where can we add this lower and upper boundary? Okay, it should be somewhere here. We will normally written down in the form of dash line. So this should be your lower boundary, and at the other side, which is on the right side, this should be the upper boundary. Okay, so since this is as well this is also known as a graph, so that means you need to have an axis. Okay, so we only have one axis, which is here. Okay, so let's say this is on the x-axis, so it will be the x. Okay, so these values will start from, it depends on the data that you have. Okay, normally this one should be about 0, and then 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and so on. Okay, depending on the data that you have. Okay, so what does it mean with Q1? Okay, so this Q1 is your first quartile. Okay, and then your Q2 is your median, and your Q3 is your upper quartile. Okay, so this three is actually the measures of central tendency. Okay, so measures of central tendency, it will have different formulas depending either you have a group data, okay, a group data, or ungrouped data. So it depends. Okay, so let's say if it's a group data, your first quartile will be a quarter of the total frequency. So what is the numbers of observation? Okay, from the calculated numbers of observation, okay, you need to refer to the table that you have and look up at the cumulative frequency. Okay, so look at it. This observation belongs to which class interval? Okay, so after you determine which class interval does this observation belongs to, so that is your class interval of your first quartile. Okay, you might not be able to see it clearly. Okay, let me show you with an example. Okay, so let's try to look at this example. Okay, so we're given a frequency distribution table which consisting of length in millimeters. So there are different pass interval given here with the frequency. Okay, so in order to make it easier for you to sketch box and plots, you need to add up another column here. Okay, which is for your cumulative frequency. Okay, so cumulative frequency. Okay, so how do we calculate cumulative frequency? Is by adding the frequency, the current class interval frequency with the previous one. Okay, so for example, in the first class interval, we only have 30 to 39 and the frequency is 4. So this is the first class interval. So previously, we don't have a class interval before 30 to 39. So that means the cumulative frequency for this one is 4. Okay. Next, for the second class interval, which is between 40 to 49, so the frequency is now 8. So previously we have 4, so 4 plus 8. So the cumulative frequency up to this new second class interval is 12. Okay, and then the third class interval, the new frequency is 10. So 4 plus 8 from the previous two class intervals, we add another 10. So in total, we will have 22. Okay, and the next class interval, which is between 60 to 69, the class interval is 9. So the new cumulative frequency is 22 plus 9, which is 31. Okay, so between 70 to 79, the new class interval is 5. Okay, the new class interval has the frequency of 5. So 31, okay, the previous cumulative frequency add up with the new frequency of the new class interval, so it becomes 36. Okay, next interval, 36 plus 3, so we got 39. And lastly, 1 in the frequency, so total 40. Okay, so the final cumulative frequency at the last row should be equivalent to the number of tuples given here, which is 40. So if you calculate the last row, the cumulative frequency is equivalent to this one. That means you already calculate your cumulative frequency correctly. But if the last one, the last cumulative frequency here is not equivalent to 40, that means there is something wrong with your calculation. So try to recalculate from the beginning. Okay, so when we are trying to find out the first quartile of this one, okay, so this one we classified as group data. Okay, why do we say so? Because we already tabulate the data and classified them according to the different class interval, and for each class interval they already have a specific they already calculate the values of the frequency. Okay, so from here we cannot specify this frequency for the first class interval come from number 31, 32 or perhaps 33. We cannot determine because we already manipulate the data and we group it according to the class interval. So that's why we call it as group data. And for the first quartile, which is Q1, it is a quarter of the total frequency here, which is 40. So a quarter of 40 is 10. Okay, so according to the cumulative frequency column that we already calculate, 10 belongs to the first class interval. 10 is it? Okay, no, it's on the second class interval. Why it is not in the first class interval? Because in the first class interval, the cumulative frequency is 4, which is less than 10. Okay, whereas in the second class interval, the cumulative frequency is 12. So that means the observation for your first quartile is in between the first and second. So automatically we will set it as at the second class interval. Okay, so that is the 10th observation. Okay, next we have to calculate what is our first quartile by using the formula lower boundary of the first quartile plus C is the class width multiply with the numbers of observation of your quartile, okay, minus cumulative frequency of the class before your quartile class, okay, and then frequency of your quartile class. Okay, so this time's observation is in 40 to 49 interval. Okay, so how do we find out this lower boundary? So LQ1 is 40 minus 0.5, which is 39.5. Okay, and your C is the class width. Okay, so which is the upper boundary. So the upper boundary should be 49 plus 0.5. So 49.5 minus 39.5, the lower boundary. So class width is 10. Okay, so NQN is the observation based on the quartile. Okay, so our number of observation for this one is 10. Okay, so F is the cumulative frequency of the class before the class interval 44 to 49, which is the class interval for your first quartile. So previously the cumulative frequency is 4, so this is 4. And the small f here stands for the frequency of the respective class interval for your quartile. So first quartile is at 40 to 49 and the frequency is 8. So your small f is 8. Okay, now after we have already all the information, we can calculate. So your Q1 and substitute into this formula. Okay, the formula might look slightly different compared to with the one in your textbook. Okay, because this one I simplify it so that I can remember it easily. Okay, easier for me to remember. Okay, so lower boundary, which is 39.5 plus C is 10. Okay, so number of observation for my first quartile is 10 minus cumulative frequency of the previous class is 4 over. Okay, now it's your turn to press the calculator and calculate the value. Okay, so it's equivalent to 47. So therefore, your first quartile is 47. And as you can see, this 47 still belongs to the same category, same class interval, which is in between 40 to 49. So that means your Q1 that you determine, you calculate is correct. Okay, so next step, you need to find out what is your median. Okay, so your Q2, okay, which is half of the observation, which is half of 40, and it is at the 20th observation. And the 20th observation, it should be at this third class interval, which is between 50 to 59. Okay, so as usual, your Q2, you can calculate by using LQ2 plus C and Q2 minus F over F. Okay, so LQ2 stands for the lower boundary of the class interval for your median, which is at between 50 to 59. So the lower boundary is 50 minus 0.5, which is equivalent to 49.5. Okay, and C is the class interval, so we can calculate by subtracting, okay, the upper boundary, which is 59.5 minus, okay, 50, the lower boundary should be 49.5, so equivalent to 10. Okay, and then NQ2 is the number of observation for your median, which is at the 20th observation. Okay, F is the cumulative frequency from the previous class, which is 12. Okay, and F, okay, is the frequency of your median class. So 50 to 59, the frequency is 10. Okay, now we already have all the information. Okay, please proceed with the calculation. Okay, so substitute into the formula. So the lower boundary is 49.5 plus 10. In the square bracket, we have 20 minus 12 over 10. Okay, so it's equivalent to 57.5. We can simply round it off into the nearest number, whole number, which is 58. And this 58 still belongs to the same class interval, which is between 50 to 59. So that means you already calculate the correct median. Okay, now let's proceed with the third information, which is your third quartile. Okay, so your third quartile should be, okay, third quartile should be 3 quarters. Okay, so remember, if its first quartile is a quarter of the observation, okay, median, it should be half of the total frequency, and third quartile should be 3 quarters. Okay, so 3 quarters times with the 40 observation, so we have 30th observation. Okay, so if we look at the frequency distribution table here, 30th observation is at the 4th class interval, which is between 60 to 69. Okay, so for us to calculate the values of your third quartile, as usual, we're going to use this formula. Q3 equals to LQ3 plus C, okay, and then NQ3, okay, minus frequency, cumulative frequency of the previous class, okay, minus over frequency of the class interval that contain your third quartile. Okay, so the lower boundary of your third quartile is 60. From the class interval, the lower boundary is 60 minus 0.5, which is 59.5. Okay, and then C is the class width. So upper boundary 69 plus 5, 0.5. So 69.5 minus lower boundary 59.5. So we got 10. Okay, so number of observation we already calculated before, which is 30. Okay, cumulative frequency of the previous class, okay, so we have is 60 to 69. So the previous class, the cumulative frequency is 22, and the frequency of the current class interval, which is 9. Okay, so now substitute into the formula. Okay, so it becomes 59.5 plus, okay, 10. Okay, so now observation is 30 minus 22 over 9. Okay, so we will get 68.4. Okay, if we round it off into the nearest whole number, it becomes 68. So that is your third quartile. Calculation, we already determined what is our first quartile, which is 47. Median is 58, and our third quartile is 68. Okay, this information should be enough, okay, if you want to sketch your box and whisker plot. Okay, so if you sketch your box and whisker plot, it should be, so this is your Q1, which is 47. Okay, and then at the end of this line is your Q3, which is 68. Okay, and then we have 58. Okay, this is your Q2 equals to 58. Okay, so this is the whisker. Okay, for this one, this should be enough, okay, to present your box and whisker plot. By don't forget to add your x-axis. Okay, so here it is at 47, and then your Q2 should be 58, and this one should be at 68. Okay, so this is it, the very basic box and whisker plot. But you also can add lower boundary, okay, as well as the upper boundary. Okay, so this lower boundary and upper boundary will be easier if you have a raw data, because the reason why we are finding out lower boundary and upper boundary is for us to identify any outliers that is present in your data. Okay. Okay, so how do we identify the lower boundary and the upper boundary? Okay, so the formula to calculate lower boundary, okay, so let's draw and highlight it here. Okay, so for your lower boundary here, okay, so we'll have this formula, which is, okay, so the lower boundary, okay, it should be Q1 minus 1.5 delta Q. Okay, and the upper boundary, okay, it should be Q3 plus 1.5 delta Q. Okay, you must be curious, what is delta Q? Okay, so this delta Q is referring to your interquartile range. Okay, so how do we calculate interquartile range? This is just simply your third quartile minus your first quartile. Okay, so this is your third quartile, which is 68, and your first quartile is 47. So your interquartile range or delta Q is 68 minus 47, which is 21. Okay, so from here we can calculate your lower boundary. So your lower boundary, okay, is your Q1 47 minus 1.5 multiplied with 21. So try to calculate. Okay, so if we calculate, we will get our lower boundary to be 15.5. Okay, and our upper boundary, okay, is Q3 plus 1.5 delta Q, and your Q3 is 68 plus 1.5 multiplied with 21. Okay, which is, the upper boundary should be 99.5. Okay, so now we can draw a more detailed box and whisker plot. Okay, so this is your box and whisker plot. Okay, this should be your x-axis. Okay, if you draw your graph in the landscape mode. Okay, so your first quartile is at 47. So 47 Q1. Okay, and then your median is 58. Okay, sorry. Okay, so this is 58 and it's your Q2. Okay, and then your third quartile is at 68. So this is your Q3. Okay, so from the table here, it shows that the lowest data is 30 and the highest data is 99. Okay, so let's say this is 100, so this is 99. Okay, 47, so let's say this is 40, and then this is your 30. Okay, so this is your box and whisker plot. Okay, then we can add on the lower boundary and the upper boundary that we find out just now. Okay, so lower boundary is at 15.5. Okay, so let's say we have continued here 20, and this is 10. Okay, so your lower boundary is at 15.5, so it should be here. Okay, so this is your lower boundary, equals to 15.5, and your upper boundary is at 99.5, which is bigger than the highest data that you have. Okay, so this is your upper boundary, equals to 99.5. Okay, so from here we can say that none of the data that we collected is out of range. That means, okay, according to the plot that we have here, okay, this box and whisker plot, all of the data is between the lower boundary and the upper boundary. So that means no outliers present. Okay, because why? Because all of the data is between the lower and upper boundary. So indirectly we can say it's within the range. Okay, so that means no outliers are present. Okay, so how do we find out what kind of distribution that we have in this box and whisker plot? Okay, so distribution, it depends on the Q1, Q2 and Q3. Okay, so let's find out the differences between your Q2 and Q1, which is 58 minus 47, so it is 11. And between Q2 to Q3, 68 minus 58, which is 10. So delta, this one is delta 1, this one is delta 2. So delta 1 is approximately the same to delta 2, which is 10. Therefore, we call it as symmetrical. Okay. Okay, the types of distribution that we have. Okay, so the first one. Okay, if you can see, we have a larger range. okay, the largest side of this data lies on the right side. Okay, even the difference between Q2 and Q3, so delta 2, and difference between Q2 and Q1, which is delta 1. So when the difference delta 2 is larger than delta 1, and you look like the graph looks like this, we call it as positively skewed distribution. Positively skewed data. Okay. Why positively skewed? Because majority of the graph, okay, majority of the data lies on the right side, which is towards the positive side. Okay, so that is the first one, positively skewed. Okay, the next one we have something like this. Okay, this is when. Okay, so this is your Q1, Q2, Q3. So this is the axis. Okay, as you can see, most of the data lies on the left side, and if you refer to the graph, mostly the left side is the negative side. Okay, and the difference, okay, between Q1 and Q2, which is the first delta, and Q2 and Q3 is delta 2. So we can see, if we calculate, delta 1 is larger than delta 2. So in this case, we call it as negatively skewed data. Okay, and lastly, we have the normal one, which is the symmetrical. Okay, Q1, Q3, and the Q2. Okay, which, okay, the difference between Q2, Q1, which is your delta 1, and the difference between your Q3 and Q2, delta 2, we say that delta 1 is equals to delta 2. Okay, so in this case, we call it as symmetrical distribution. Okay, you will learn more about this later on in towards the end of your terms 2. Okay, thank you for watching. I hope this video will help to encourage you to complete and finish up your project-based learning. Thank you for watching.